Hello and welcome to From A to Z Azure Virtual Conference. I am Kit Skinner and I will be your trainer for this session on Azure Infrastructure as a Service. Give you a little background about myself. I am a trainer here at Opsagility. I do a lot of hands-on training as well as course. Prior to working with Opsagility, I did spend several years doing Azure consulting, especially with a lot of focus on infrastructure and security as services. Before that, I spent several years in IT in the trenches, everything from help desk all the way up to data center architecture and migration. So I hope to try and bring a lot of that expertise and knowledge to y'all and give y'all a good understanding of what's going on in the environments. So in this particular session, we're going to go over a lot of the different options that are in IaaS, the infrastructure as a service environment with Azure, especially around infrastructure as a service itself, what it is, some policy and governance options that we have around it, as well as how we can control the costs around IaaS. First off, let's start talking about what IaaS is. Again, infrastructure as a service, IaaS. To kind of get a good idea, there's a comparison that's made between a lot of the different models of services that are out. There's the four main models: the on-premise or private cloud or something that you run yourself, where basically you're responsible for all services in that particular realm. However, as you continue to move up the stack, whether it be infrastructure, platform service, software service, you'll see that slowly cloud providers taking over more and more responsibilities. Um, but in the end, you're always responsible for data and manage, regardless of what platform you're in. However, this particular area, we're going to focus on the infrastructure as a service pieces. This is where we're talking about the actual virtual machines, operating systems you continue to run and operate. However, the cloud service, in this case Azure, is taking over the responsibility for all the underlying compute and networking and storage infrastructure that's required to support it. That's also going to include everything like physical security, making sure the hardware is up and running. All those sorts of things are handled by the cloud provider. We're going to be focusing on how we can manage and continue to control the virtual machine environment, the operating system, and make sure that we have all the runtime and application information in there, as well as the data and access to that information. And again, when we're looking at these, the cloud services, you can kind of think of stacking on each other. A lot of times the upper level you can think of as being SaaS. This would be something like Office 365 or Salesforce or any other number of services that are basically where they control the entire application. They're responsible for managing it, and you're basically utilizing the data and the application itself. Those are generally going to be running on top of a PaaS service, but you could also deploy your own PaaS services. Those could be something like a database system, like SQL Server in Azure or web app running in Azure, something like that would be considered a PaaS service, something where the application still has to be run and configured on top of it. However, you're kind of controlling the main pieces of it, and the provider is actually providing the control and the monitoring of the infrastructure and the services that provide that platform to you. Yeah. Then when you go down the stack, that's when you start to get into IaaS. And then in an IaaS environment, especially something like we're working with Azure, you're looking at a kind of pay-as-you-go model. Even in the agreements that you have with Azure, if you're going to be running long-term environments, if you're going to be running dedicated systems, technically speaking, you're still paying for those resources as you go. So even though you may have commitments, you're not necessarily committed into individual systems a lot of times. Usually there is some flexibility around it, and usually it's based around the usage of those resources. But the idea here is that you're using these in an environment. You're not having to worry about going out and paying for full hardware. You're not having to set up a lease agreement. You're paying for a virtualized environment where you can run the systems as you need it, and as you need those additional processing power and additional resources, they'll run on top of it. Now, generally speaking, an IaaS environment would be something that would be made up of servers and storage, networking, and then the physical environment is going to be managed by the cloud provider itself. Now, the servers and storage are going to be running in a virtual sense. You're not going to be managing the underlying hosts, unless you buy a dedicated server, in which case the line blurs a little bit. But even in those scenarios, you're not having to manage the blade, the physical hardware. You're not having to worry about the interconnectivity between the storage subsystem and the server itself. Instead, what it is that you tell it that you need a virtual machine that has X number of cores, X number of RAM, and you need to have X amount of storage, and then the cloud provider goes off and provisions that for you, and then you spin up your virtual machine on that platform. All that underlying RAID arrays, all the making sure that you have enough CPU available for your individual system, all of that's handled by the cloud provider. You're not having to manage that in an IaaS environment. You are still having to manage the operating system, though. You're still having to do things like patch the operating system. You're still having to make sure that it's responding appropriately, that you're getting a heartbeat back from that operating system, that it's continuing to run the services. You need to monitor the logs to make sure there's not somebody trying to log into it inadvertently, somebody trying to hack into it. You also need to make sure the applications are running in it are not generating errors, or the operating system isn't generating errors. Those are things that you need to continue to do in an IaaS environment. While we've been able to abstract away all the hardware and underlying pieces, there are still a lot of pieces that you need to be responsible for maintaining in an IaaS environment. From a networking perspective, again, you're not having to worry about the physical network connectivity. You're not having to set up VLAN environments. You're not having to set up and configure the switching. You're not having to do a lot of the lower level networking pieces. However, you do still have to define things like the address, private address space you're going to be using for what's called a virtual network. Talk about that in just a second, and then also the underlying subnetting and network traffic between that. Now, the cloud provider itself will provision where interconnectivity is needed, as long as you tell, I need this VM to talk to this VM across this VNet. That's provisioned. You don't have to worry about making sure that the VLAN has been moved across and transmitted through all your switch stacks. You are assured that if you're connecting in the same region and you want virtual machines to be on the same VNet, they can talk to each other. And that's what the IaaS system is going to provide to you. You don't have to worry about the underlying networking. You just tell it what you want the networking to be, and they will handle the interconnectivity. You also then define what the allowed connectivity is. There's a function called network security groups, where you basically say these IP addresses are allowed or these IP addresses are denied, and you can set that up in your networking. And again, that's not super advanced values there. There are some other tools that we can add on top of it, including firewalls and application gateways and public IP addressing, private endpoints, all sorts of other things we can do with that networking as well. But we have to understand that we're not having to maintain the underlying connectivity, and we're not having to maintain and monitor the throughput of each individual wire, making sure that we don't have an uplink port that's being overloaded. That again is handled all by the cloud provider. We're more worried about the design and the interconnectivity of the systems. We're not having to worry about the underlying physical abstract or underlying physical pieces to make sure they are maintained and are able to support it. That's going to be handled by the cloud provider. And then the data center and physical is almost entirely managed by the cloud provider. The big thing is that you tell it what physical facility you want to be in. There is some options around zoning in Azure in certain regions where we tell what type or what building we want it to be in, as far as what zone within a region. But beyond that, we don't go further down into it as far as making sure where it is. We don't have to maintain the powers. We don't have to maintain the air conditioning, the cooling. All that is, again, handled by the cloud provider. So that's all something that's baked into the cost and baked into the overall management. Those are not something we're having to do in an IaaS environment. And that's one reason why we've talked about moving into the clouds, is having to move away from those finer tuned pieces. When we get into the networking, this is an example of a common networking scenario that we would use in an IaaS environment. In this particular case, we're going to be talking about a hybrid networking solution that would be with an on-premise environment that is then connected up to a cloud networking space. This is a very common scenario, especially for people that are first moving into Azure, because most likely there are scenarios that you have or systems that you have on premise that you still need to communicate with, you still need to talk to. And a lot of those are probably used to talking over a private networking space. They're not used to talking across a public cloud. They may not have all the interfaces set up. Your security systems may not be configured to deal with that. And so in those scenarios, we probably want to continue to do private networking. In this case, what we can do is set up a virtual network in Azure. You put in a VPN gateway into that virtual network, And then we can create a VPN tunnel to your on-premise environment. Most facilities have a VPN these days. Usually, you have multiple different sites that you're talking to each other, and you have your VPN system that you're talking to. That is what the Azure VPN gateway can then talk to, is just another endpoint. And then just like you would route your communication to another site within your virtual network, you can also use that to connect up into Azure across a VPN tunnel and do that across your internet connection, but it gives you a nice private communication. Then what you can do in Azure is what's called a peering with the gateway transit with other virtual networks in the same region. What this allows you to do is those virtual networks can then talk to that central VNet that has the VPN gateway on it. That can then act as a hub gateway, set up a hub and spoke architecture, and they can all use that same VPN tunnel. That way you don't have to have multiple different VPN connections, and you can just maintain one or two per region, for redundancy. This is also a similar setup if you use what they call an express route. Express route is similar to a VPN communication, but it's a dedicated connection with your telco provider to get you connected into Azure. It's a similar type of setup. Which brings me to another common resource that we use in the infrastructure as a service. Because again, the infrastructure as a service is usually based around us running something like a virtual machine. Because this is something that needs to do traditional networking for whatever reason. These are not managed services like we would have with SQL database systems or Azure web apps or container systems. This is something where you're needing to have control over that operating system for some reason. Whether it be an application that's the way it was designed, that's where it was done before, you haven't gone into evaluate whether your application can work in a web app scenario or something like that. In those particular cases, you need to make sure that you continue to have virtual machines in there, and that's why we have an infrastructure service generally, is because we're using virtual machines for some reason. So almost all infrastructure as a service solutions, you'll have virtual machines in place. If you haven't worked with virtual machines before, the idea here is that we have an operating system like you would have running on your laptop, running on a server, or whatever. In this particular case, we have an operating system that's running in the cloud and has a machine for you to connect to. Okay. There's going to be a processor associated with it, so you're going to have 1 core, 2 core, 4 cores, 8 cores, 16 cores, and then you're also going to have an amount of memory that's associated with it: 2 gig, 4 gig, 8 gig, 16 gig, 32 gig. Then associated, also attached to that virtual machine, is going to be storage. And that storage is going to be a disk that's going to run an operating system, and maybe a disk that stores some data. You may pair multiple different disks together. You may put a software RAID in the virtual machine to stripe those disks together to make them appear as one disk. There's a few different options around that, around your storage, but the idea is that you don't actually have a physical disk you're attached to, you're just a virtual disk image that you're connecting to. And then finally, the networking of that virtual machine to talk to the network and have it communicate with that virtual network we talked about before. Now, again, you may have multiple different processors, multiple different amounts of RAM, multiple storage disks attached to it, and multiple NICs, network interface cards, you may have attached to a virtual machine as well. Now, the amount of resources that you have attached to that virtual machine is going to be defined by the size of the virtual machine. And there's specific sizes that are available in Azure, but they tend to fall into general categories as far as whether you need something with a general purpose virtual machine, a compute-heavy virtual machine, a network-heavy virtual machine, a storage-heavy virtual machine, processing-heavy virtual machine, or RAM-heavy virtual machine. A few different options around that. But within each one of those, basically the ratio of CPU to RAM to storage is going to vary based on what the intention of the virtual machine is. So if you need something with more processing power, you pick one with additional CPU cores. If you need one that needs additional RAM, then you pick the one that has additional RAM. And then as you go up in size, more resources are available to it. And as you run that virtual machine, as it's in a running state, the compute cost will be associated with that virtual machine while it's running. The other thing to make sure of in Azure is that if you shut down a virtual machine, you go into Azure and you tell it to stop that virtual machine and deallocate it. If you just go into the virtual machine and tell it to shut down, that doesn't necessarily tell Azure to deallocate that resource, but the resources are still allocated, which means you're still going to be charged for those resources, even if they're not really in use, as long as they're allocated. So you need to make sure that they're stopped. And again, IaaS, because you have direct access to the virtual machine, you can make any configuration changes to the virtual machine that you need to, any registry entries, you can add in any application that runs into it. You can make any customization to that virtual machine that you need. Obviously, there's a couple limitations because you don't have access to physical hardware. Beyond that, the operating system is your environment to manage and control as much as you need. However, that operating system is your responsibility, so you need to make sure that you're maintaining and monitoring it appropriately. Some additional services that are usually associated with IaaS is going to be container-based storage, usually like a blob type storage. And there's also what's called disk storage or managed disks. In those particular instances, you actually would have a resource that is associated with your virtual machine. This is usually the preferred method these days, to have a managed disk attached to your virtual machine, just because that way you have that additional resource right there with it, and it's called out explicitly rather than having to go find that disk inside of a storage account and having to maintain a separate storage account just to keep your disk in. It's usually much easier to use a managed disk, and it also gives you some configuration options, some dynamic changes of your tiering that you can do that you wouldn't be able to do immediately in a storage account. In addition, they have what are called the Azure Files in the storage account. The Azure Files is an SMB storage system that would connect up to either the public internet or a private virtual network. These can then act as a file server, and it can use NTFS permissions across the SMB connection in order to have those shares directly available to your virtual machines. And then in addition, in an IaaS environment, we start to get very much into the defense in depth concepts. What they mean by defense in depth is that we aren't just doing one or two things necessarily to secure an environment. There's usually multiple different steps that we do to achieve this. Now, for as far as physical security is concerned, because you're in an Azure IaaS environment, that physical security is going to be maintained and controlled by Azure because that's part of their control and responsibility realm. They'll be making sure that that facility is kept secured, that people can't get into it. They'll also be physically encrypting those disks so that if someone were able to get a hold of an old disk, the data that would be on there would be encrypted and unusable to them. And then you can start to get into more of the identity and access controls. When you start getting access in the environment, there's a Azure AD interface to allow you to control access to it, and it's used by all of Azure as well as for Office 365, Microsoft 365, and most other Microsoft Cloud solutions, as well as third-party services integrating with additional services outside of Azure. It can be an identity provider, so we can control the identity and access to not only Azure and other Microsoft resources, but outside resources by having that identity provider. That then gives us a way to control and manage that environment. So that's saying who would have access to you and who would be authorized to get into your environment. And then you can start to get into the perimeter security. And these are going to be things like edge devices like firewalls, application gateways, VPN gateway concentrators, those sorts of things. The perimeter is going to be something where you're going to control access coming into the environment. Then you start to dive down into the networking controls. Now, this is usually networking within your environment. So rather than something at the edge and the perimeter, with something inside your network. And this can be an Azure firewall that's protecting communications in between, or it can be a simple network security gate group. Or it can be something as simple as network security group, where you have communications coming from your different environments that are identifying that this subnet has access to this other subnet, or this virtual machine has access to a virtual machine. This is a very common scenario where we'll put maybe a three-tiered application where you have a web front end, a middle tier app, and a backend database, and we'll put a subnet for each one of those types of resources. Put all your front end into the front end subnet. Put your middle tier application into your app tier subnet in the middle, and then put a database storage on the back end. And then you can set up the NSGs to say that the front end can talk to the app tier, and the app tier can talk to the database, but no other communication can happen between those. That way you can assure if somebody were to compromise a front-end web service, they would not have direct access to your database system. The idea behind defense in depth is that we're continuing to try and limit that access, and this also comes into what's called a zero trust model. We're trying to limit the access from any one point with the understanding that there is always that potential that one particular point could become compromised. Well, if we make sure that that point only has access to what it needs, the front end never needs to have direct access to the database. So we never give that access. The middle tier should only be talking to the database and should only be responding to the front end. It shouldn't be reaching out to the front end. It shouldn't be talking directly to the internet. Those types of things we can put into place. And that's at the network piece. And then the compute level, we can make sure that we're running threat protection on the operating system. It's looking for unusual activity, making sure that what's going on in the environment is controlled and what's expected. And then we get into the application and data. You're developing your application. There's several different things that you can do to help integrate. There's some insights. There's the development process, making sure that you have good checks on your code and that it's being thoroughly vetted, that information coming into play. As far as the data is concerned, you can also make sure that who has access to that data, what type of controls are supposed to be coming into it. You can put in data protection onto it. You can encrypt that data several different ways. So the idea here is that by having an infrastructure as a service, we're able to control everything from the identity access all the way down to the individual data. And we can take different measures at each step along the way to make sure that we have security in place. And so that if there's ever one compromise along the level, it's not exposed the entire environment. A lot of old traditional environments, sometimes they would put perimeter security in place. And then if you were inside your internal network, they basically allowed communication internally. It was a very naive approach, and it caused a lot of problems. They assume that if you're in their private network and you're supposed to be able to RDP from one system to the next. That's not something that we need to be expecting in a modern environment. We don't expect all systems to be able to talk across all points just because you happen to be in my private network. So this is where we get into a lot of the defense in depth scenarios. Lots of different options, lots of different ways we secure the environment, and a lot of these tools are built into Azure by default. Some of these are additional add-on services, but things like network security groups. Another piece when we're dealing with the infrastructure service is making sure that we have the proper security and governance behind this. And we can do this with policy and governance of our infrastructure service environment by utilizing many of the tools available to us. Now, you heard me talk about the identity and access earlier, and that's primarily provided by Azure Active Directory, often referred to as Azure AD or sometimes AAD. But in this particular environment, what we have is the users and groups all contained within the identity provider of Azure AD. This allows us to authenticate users to not only Azure resources, but Microsoft 365 and additional services that either we develop or applications that we attach to externally, and provide that single sign-on for the user to be able to authenticate into the environment. We can also then monitor this environment for any unusual activity, either by groups of users or individual users. We can also enable multi-factor authentication at this point. We can determine who has access to what application. We can first have them authenticate and say who they are, and then we can authorize them for individual applications. We can do this by groups or individuals. We can also then bring in guests from external organizations, partner organizations with business to business or B2B connections. So if you have people that are already using Azure Active Directory in their environments and their companies, and we want to grant them access to a particular place, we can bring in their identity as a guest into our B2B, and then we can grant that guest account explicit access to individual resources. We can also add them to groups and give them conditional access into our space as well. We can also utilize business to consumer application for our identities of our application. So if we want to be able to allow users to authenticate either to Microsoft accounts or Google or Facebook or many other consumer environments, they can continue to use their consumer identities to access our applications that we develop. That's the business to consumer environment. Now we can also do device management and have our trusted devices, have our known devices that we want to control and authorize for it. And this can all be handled in the single Azure AD environment for all these different scenarios. We can also utilize this for our IaaS environments, and we can say who has access to manage our IaaS environment. We can also integrate this with our traditional Active Directory or Active Directory domain services and have our Windows servers be able to use the same identities that we use for Azure AD to authenticate to the environment to access the virtual machines themselves as well. In addition, the Active Directory services give an optional service that we call Conditional Access. What this conditional access is, that brings in 4 different types of signals and lets us determine how we want to deal with that signal, or then we determine how we want to deal with those signals to allow access or deny access to a particular data set. To allow access or deny access to a particular application or data set. The 4 main signals are the users, where they're at, the application that they're trying to access, what device they're using to access the environment, and a real-time risk assessment. Those main 4 signals we can use then to determine whether we're going to allow access or require an additional challenge from a multi-factor authentication, or if we're going to just explicitly deny access. For instance, if you had a particular application that maybe was a high security application, for instance, maybe an application like the management interface for your application, and you knew that they need to only be accessing it from your company sites, from your company facilities. You could say that this administrative users, or the users in the administrative group, and as long as they're accessing it from a trusted location, and if they're accessing the administrative application, and it's from a trusted device, and we have a low real-time risk assessment, if that's there, then maybe we allow them access. Maybe we need to go and challenge them for multi-factor authentication because it's a high security administrative tool. And then we could say if it doesn't match any one of those 4 signals, then we just deny their access. And this happens before anything has even touched the application. This is the gateway to get into those applications. Right. So these are the different things that we can do with conditional access. You can also set up to say, most users, if they log in from anywhere in the world and it's their normal login process and everything looks fine, we can grant them access, once they've obviously authenticated, we can grant them access to Microsoft 365. However, if they do a login and the real-time risk assessment sees that there's maybe medium risk here, maybe there's something else going on, maybe we can do an additional challenge for multi-factor authentication so that we can, if it's something that maybe is a compromised login and it's not actually the user logging into it, we can then send a multi-factor authentication challenge to them and say, hey, enter this code. It may not be something you do on a regular basis because it's a convenience factor for most of your users, but if we've done a real-time assessment to say that this is unusual activity for this user, normally they're logging in on the East Coast and all of a sudden this one's logging in from Alaska, and this is an unusual activity for that user. Maybe we need to challenge them. That's something that would come up in a real-time risk assessment. So those types of things may be something that's unusual, and we can do that additional challenge. And again, this is all done before anybody even accesses any of the application. Once you've been authenticated to the environment, we've been allowed into an application, then we can define what type of access you have within that application. In this particular case with Azure, in the management of the infrastructure, we can set up what are called role-based access controls. By default, in Azure, you don't have access to anything. Just because you're in Azure AD, you don't have access to even see anything in the Azure space until you've been granted some form of access. And those roles in Azure are defined as a role definition. And that role definition would be included everything, all the permissions are needed to perform a particular task. For instance, a virtual machine contributor is somebody who maybe manages and controls the virtual machines in a particular scope of environment. They can create virtual machines, shut down virtual machines, and control those virtual machines. And they have the ability to see all that information for those virtual machines. And you could grant a user, a group, access to your subscription to manage all those virtual machines. For instance, maybe help desk type coverage or IT type of team that they need to be able to log into the virtual machines, do patching, check all the monitoring, and those sorts of things. However, maybe that team does not need to have access to your database systems. Maybe that's handled by your DBAs. In which case, just because they're a member of virtual machine contributor, they won't be able to see into your SQL BAS systems. They would only have access to see the virtual machines. So if you have that stored in different types of data, or excuse me, different types of resources, they would have access elsewhere. You can also separate out things in different resource groups. So maybe you put all the virtual machines that they're needing to monitor for the main team and the primary resource group, and then whatever they're using for databases, for database servers, you can put those into a different resource group, and you can grant them access to only the resource groups that they should have access to. And just because they have access to one resource group doesn't mean they have access to anything else in the other resource group. Resource groups themselves are just a structure for us to organize our resources together and put everything together in one particular group setting. Every resource is in one resource group and one resource group only. So this allows us to organize and control the structure of the environment. We can also grant access based on groups or based on application. Or even other resources. We can give managed identities to resources. So you can set up an automation account and have it have access to virtual machines if you want. Lots of different things around this. The idea behind RBAC is that you grant people access to those resources that they need for their role, and then they're granted full access, or they're granted access to perform those roles and only those roles. And the RBAC roles are then additive, so if you need them to do an additional task, you give them an additional role. They're granted those additional rights for whatever scope you gave them. None of the roles are going to deny any access from one to the other, so you just add on additional roles as needed. You can also create custom roles. Then conversely, there's what are called policies. Role-based access control, again, you had no access to everything, although once you've been granted a right, you can do anything within that right's permissions without any limitations other than what that right allows you to do. Policies start to bring in those rights and start to control and kind of put you in some guardrails. For instance, when you create a virtual machine, the role for the virtual machine contributor allows you to create a virtual machine, but you could go out there and theoretically name it whatever you wanted to. However, you could set up a policy that says, okay, all of our virtual machines need to have this particular naming format. Maybe it needs to be 4 letters followed by 2 numbers. Or it needs to have a dash in the middle of it. Whatever it is, you can set up a naming policy as part of your standard. Now, even though a virtual machine contributor can go out there and create a virtual machine, and he could theoretically give his name whatever he wants, the policy is actually going to say, no, you have to name it this way. Now, policies will never stop a virtual machine, and it will stop a process out there if it's in violation. If you create a new policy, it's never going to go out there and just stop you from, or stop a system that's running out there. But it will give back a report saying, hey, this virtual machine is not in compliance. But you can also set up the policies where anytime a change is made, it will make sure that that change passes the policy. And if it violates the policy, it will deny that change. And then the system will continue on how it was before the change was attempted. And it'll just throw up the error saying, hey, you can't make this change because of this policy. All right. So in that particular case, you can set up a policy in for names of virtual machines. As soon as you create it, it's going to go out there and start generating it for you. They'll come back with a report and say, okay, here's all the virtual machines that have the wrong name. However, as soon as you create that virtual machine, you send it to a scope, if somebody goes to create that virtual machine, violates that policy, then they wouldn't even be able to create the virtual machine. Then beyond that, this is just, that example was the name of a virtual machine. You can do this with just about any setting within Azure itself, whether it be a tag, size of a virtual machine, maybe a particular attribute associated to it, an extension added into it, network ports that were open. Any policy or any setting, that is associated with the resource can be defined in your policy. There are also lots of policies that are out there already generated by Azure to make sure that your environment is under HIPAA compliant or NIST compliant. And so what those do is they've grouped up all these policies together into what's called an initiative. Initiative, just a group of policies, and we can assign that NIST initiative to your subscription. And then we can come back and say, okay, here's all the things that are not NIST compliant. Here's what the settings are. It'll group it down to each individual policy, what's the violations are. You can look at by resource, see what's not compliant. And there's also documentation with each one of those saying, okay, this is what's not compliant. Here's what you need to do. Here's a link to an article. Sometimes there's also remediation steps where you can actually just click a button, and that button will then go out and make change for you. So there's lots of different options around policies. The idea behind policies is that we're trying to make sure that we have good standards around whatever we're creating. RBAC roles give you the ability to do things. Policies make sure you're consistent in maintaining good standards of whatever you're doing. That's how those two work together. Then we have Microsoft Defender for Cloud, and this is where we can take those policy alerts and any of the other security alerts from our different services and be able to identify what's happening in our environment, and if we're running into any additional issues or any policy violations, any security threats that were detected by different endpoints will all be brought together in a Microsoft Defender Cloud. This works for your IaaS environments when you're enabling the Defender for endpoints, as well as any other policies that you define. Those will show up in here. So it's a nice centralized tool for you to be able to monitor the security of your environment and what you'd be doing those. And then, as with any pay-as-you-go type of environment, anywhere we're going to be doing a consumption-based model, we want to make sure we're going to control our costs, and infrastructure as a service is no different on that. As with any consumption service, there's always going to be different factors that affect your costs. In this case, there are 6 main factors that contribute to any costs in your Azure Infrastructure as a Service solution. The first one being the resource type, whether it be a storage account, virtual machine, disks, database, firewall. There's different types of resources have different pricing models, so you need to make sure to look at the different types of resources you're deploying to determine what your costs are going to be. In addition, any additional services that are bought alongside it, whether it be support services or cloud service provider services, whatever is included in your service can affect your costs, as well as how you're purchasing it. Again, whether it be an enterprise agreement, direct purchasing, or CSP. Then there's also the location that is that you're deploying to. Different regions have different costs. There's going to be costs associated with power and cooling, as well as with geographical and real estate type of costs that are going to be associated with it. So you need to make sure that you're looking at the different costs when you're deciding to deploy to a particular region. It may make sense for you to maybe move to a slightly different region for cost saving needs, but again, it depends on what your deployment needs are. Maybe you need to have something deployed in that same region because you're already deployed there, or it's just what is closer in your particular jurisdictions. But it may make sense to have a slightly different deployment in a different region. Then there's also three additional factors. The bandwidth. Most data that's coming into Azure is not charged. However, data that leaves Azure tends to have a charge behind it. Sometimes there's also a charge going between different regions. Going cross-peering, there can be some charges. So look at what the bandwidth is along it. And also there's some options around reserved instances. If you can commit to a particular size and resources for a period with Azure, they can give you a discount for it. There's lots of different options around those. So look at the reserved instances. You may find that you can actually get a significant amount of savings on a reserved instance in an Azure environment. And then there's also what's called hybrid use benefits, or sometimes referred to as AHUB. And these are licensing options that allow you to utilize an existing software assurance agreement that you have for on-premise resources and use those for discounts in the cloud. There's also a pricing calculator that's available for Azure. There's several different scenarios out there already as pre-configured settings to start off with. You can also go through and pick off the major resource types that you would utilize in your deployment, and you can help identify what those costs would be. You can pick the region, pick the sizing, and pick the different options that you would look to see and how they're going to affect your costs dynamically directly in the pricing calculator. You can then save all that information for future use. You can email it to yourself. You can also share it with colleagues. So there's lots of different options there for you to document and keep track of what your costs are. It can also help you if you're doing a deployment, especially an early deployment, and you do an estimation and then look at your bill afterwards and make sure it was consistent with what you estimated. If it's inconsistent, you may want to go back and look at your pricing calculator, determine what you put in there, and determine what came out, and figure out where those inconsistencies are, and help determine if your future estimates um, to make sure that they're more accurate going forward. There's also a total cost of ownership calculator. Again, this is something to help you determine what your costs are going to be going forward. This is something that you can utilize to help see what you're paying on premise versus what you'd be paying in Azure. Um, this particular one is a very aggressive model, but there was also a lot of data center costs that were able to be removed. So lots of different options around it. That's definitely something that's available as well to help you determine going to the cloud, the benefits around that. And then there's also the cost management. And what the cost management is live reporting within Azure, helping you determine what your ongoing costs are, and also give you projections on what's expected to be for the month. You can also then put in budgetary alerts and help you identify when you're approaching a certain limit. If the rate of consumption is going to exceed your budgetary numbers, you can have it send off an alert ahead of time so you can start either identifying maybe something that is consuming more resources than it's supposed to, or perhaps you need to be identifying that maybe there's going to be a little bit hit to your budget this month because there's more growth than expected. And so that we can also start compensating and saying, okay, we had these additional costs coming up, but that's because we were also doing this additional business. And that way you can kind of offset that and be prepared for that information. Um, but it also helps you determine exactly what it is that's consuming those resources or consuming that cost. You can dive into individual resource groups, you can dive into regions, you can dive into individual resources and help to see what those costs are that are coming into your environment. And that way you can help determine what it is that is using those pieces. There's also recommendations advisors in here that will tell you, hey, this virtual machine was at this level and you've only been using 10% of the CPU for the past 2 weeks. Maybe you need to drop the size of that VM because it's just too big and you're paying for a lot of resources you're not using. So drop it down to this size. Those types of things do come up in the recommendations. You have to keep in mind, yes, just like any other business, Azure is in it to make money, but part of that is making sure you're happy with that service. And if you're paying more than what you expected, and you're paying more money because they're having to allocate those resources and you're not using them, you're not going to be happy. But if they can give you other resources for that same money and give you more bang for your buck, they expect you to be happy, and so they're going to try and give you these tools to help identify what you can do better. Help you find ways that maybe you could squeeze more efficiency out of your dollar. So again, minimizing those costs. You can use the Azure pricing and TCO calculators ahead of time to help identify what's going on. Monitor your environment with the monitor as well as the advisor. Set up spending limits and reservations to help utilize your resources and let you know if you're going to be hitting into any limits. Make sure you're using the low-cost locations when possible. Make sure you're staying up to date with whatever offers and subscriptions are out there. You can set up alerts to let you know when those are coming through. You can also apply tags for resources in Azure. If you have worked with Azure before, tagging is basically a key value pair that allows you to specify whatever information you want to have associated with your resources. For instance, you can put something in there like a cost center. You can have a cost center tag that then puts the number value for whatever cost center it is, and you can filter out all those resources for it. And you can also do that in the cost analysis as well as in your invoicing. So you can help identify, who the owner is of a particular resource, and let them identify what those costs are and help them identify, how they're utilizing their money and maybe some better ways that they can utilize it. All right, so we kind of went over what IaaS is, some of the policy and governance tools that we can have around it, as well as ways to control those costs. Appreciate you very much for coming out. Again, my name is Kit Skinner. This has been the A to Z for Infrastructure as a Service. Thank you very much for attending. We appreciate it.